Hello, good afternoon. Today I'm going to upload a video in YouTube on the one of the topic from Nepal Electric Authority from the stream of mechanical engineering. As we all know, Nepal Electric Authority has recently published an open competitions announcement of an open competitions in the different technicals and non-technical posts. So in technical post there is few vacancies for mechanical engineers. Relatively mechanical student feels very difficulty on preparing because the required materials and sources are very less available here. So in hope to help them, I'm preparing I'm just uploading this video. So the video will be one of the topic from NEA. This is the diesel engine power plant. So I think uh, 15 or 18 marks questions is being asked from this unit. So we'll be discuss about diesel engine power plant. So we'll discuss what the diesel engine is, what diesel engine power plant means, and what are the engines being used in diesel engine power plant, what are their applications, advantages, disadvantages, and their layout, and accessories and components required for diesel engine power plants, right, for the smooth operation and functioning. So all things will be discussed in this video. So let's just start from the right beginning. So a power plant is something which is the arrangement of engine accessories components for the productions of a power. Similarly, in diesel engine power plant, the diesel as a fuel is being used for the production of a power. We all know diesel and petrols are type of a chemical fuels which has their calorific values. Like diesels have calorific value of around 45.5 megajoule per kilograms, right? The petrols has 45.48 45.8 megajoule per kilograms. So these are the calorific value. So that much of energy can be liberated out by the burning of 1 kilogram of fuel of the diesel. So diesel, why diesel is being used as a power plant? So one main reasons is diesel is relatively cheaper than petrol. Okay, and diesel is most one of the most popular sources or fuels, which is why it is being used in the power plant. That is very capable of producing the small to medium scale power productions, which is in the range of 2 to 50 megawatt. And also the diesel power plant can be used as a supplementary power plant in the hydroelectrical and steam power plants as standby units for starting from cold and under emergency conditions. So these are the few reasons which makes the use of diesels as a fuel in the power plant, and the power is being or load is being uh, produced. So the selection of engines, what type of engines should to be selected and should to be used for the production of a power in diesel engine power plant? So the engine, IC engine itself. So IC engine is further classified as a diesel engine, petrol engine, two-stroke engine, four-stroke engine. So I does not need to describe much and more about these things, because the guys from mechanical engineering will know about these things. So in a brief, in little, we'll say that the diesel engines is the one which uses diesels as a fuel and does not needs any uh, external sources for the spark, like, because the diesel is a kinds of fuel which has uh, the self ignition temperature is very low, like 210 degrees Celsius. So when the diesel is compressed, when the air is compressed inside the engine cylinders, the compressed air becomes at a temperature of 210 degrees Celsius, and at the time the diesel is injected, then it's get ignited itself. It does not require the external spark plugs. as it is required in the petrol, because those have the self-ignition temperatures a little more, 247 to 280 degrees Celsius range. And there is four stroke and two stroke engine. I does not need to describe more. In two stroke engine, the working cycle is completed in two strokes and one complete revolution of the cranks, whereas in four stroke cycle engines, the working cycle completed in four stroke inlet or suction stroke, compression stroke, then power stroke, exhaust strokes, and in two complete revolution of the crankshaft. Right. So there is the advantages of using two stroke and four stroke engine. Two stroke engines relatively occupies less area and theoretically can generate twice the power as that of the four stroke engines, right? And also the torquing effect produced by two stroke engine is more uniform than four stroke engine, and the flywheel required is lighter. It's not messy, not a bigger one. So we can say the mechanical efficiency achieved by two stroke is also higher than the four stroke engine. And the four stroke engine is very economic, because it uses uh, the whole fuels inside the cylinders, uh, and converts it into the power stroke, and less fuel is form of smokes and other gases like carbon dioxide, monoxide, sulfur. It came out from the exhaust systems. So that is the advantages of four stroke diesel engine power plants, right? Four stroke cycle engine, sorry. Now there is the selections of the engines on the basis of fuels. So there are two types of, we call as the dual fuel engines. So the name itself indicates that the engines which uses two types of fuels comes under the dual fuel engines. So the one is the primary fuels, which is the gaseous fuels, and this is the ignition fuels. Another one is the oil, which is just in the purpose to ignite the fuel, ignite the gaseous fuels. So here the gas is compressed into the engine cylinders, and the fuel is injected at the end of the compression stroke, so that the combustion takes place inside the engine of the cylinder, and power is being generated. So this type of engine is very economic, because this engine uses the waste gases, fuel as a waste gases, that is from the sewage treatment of a plant and oil wells. So that is very economic, right? So that is about the dual fuel engines. Now what is the applications of using the petrol diesel power plants? What are the applications of diesel engine power plants? So there are few applications of diesel engine power plants. They are standby units. So diesel engine power plants can be used as a standby unit in the hydroelectric power plant, steam power plant, whenever they are required. Okay. Another is the peak load demand. So whenever there is a traffic in consumption of the power, the diesel engine power plant can be used as an alternative source to reach the peak demand, along with the hydro power plant, electrical power plants, or steam engine power plant. Okay, because it's can be easily started and can reach the uh, reach the peak value in a very short periods of a time, right? So, and also it can be used as an emergency unit whenever there is problem in the main power plant. Then diesel engines can be used as an emergency unit in the places like hospital, uh, barrel, um, tunnels, sorry, uh, in mining works, and in the main power stations itself. So this can be used as the emergency power sources. This can be used as mobile applications. So diesel engine power plants can be used as the mobile applications, as the power source at the working site, right? So this can be used as the mobile applications. Another is the starting units. This can be used as the starting units. So for the starting of main engines or hydroelectrical power plants or other engines, the diesel engines can be used as the starting units for them, right? because they can um, stand by units starting from faults and under emergency conditions, right? So these are the applications of diesel engine power plants. Now what are the advantages of using diesel engine power plants? What are the advantages? There are few advantages which makes the use of diesel engine power plants. They are as follows. Diesel engine power plants, the if you see the layout of diesel engine power plant, then it is very easy. So we can say that the layout of diesel engine power plant, or foundation of diesel engine power plant, is very easy. Fuel handling in diesel engine power plant is comparatively easy. Okay, and no problems of refuse disposals, like as it in other other power plants, like as in nuclear power plants. Okay, so because there is no is like wastage from the diesel engine power plants. Okay, and it is not required large amount of water for cooling purpose as it is required for steam engine power plant, right? The operations and starting of diesel engine power plant is very easy, and it can easily reach and pick the desired load at in a very short periods of a time. Okay, and also comparatively diesel engine power plants produces more power, uh, is the uh, is area or space occupied, right? The operations and maintenance of a diesel engine power plant is easy and requires less labor, we can say. Comparatively, diesel engine power plants produces more thermal efficiency. There is no standby losses, and we can say comparatively diesel engine power plant life is also uh, more than other power plant. So these are few advantages of diesel engine power plants. Now we will talk the few disadvantages of diesel engine plants. So what are the disadvantages of diesel engine power plants? So the disadvantages of diesel engine power plants are the unit capacity of diesel engine power plant are comparatively low. Another is the diesel itself is an expensive fuel, and hence the power production's cost will be higher. Foreign power production cost will be higher. The maintenance cost will be little higher in diesel engine power plants. And lubricating, cooling, these are some messy functions which has to be performed in diesel engine power plants. So these are few disadvantages. Also, diesel engines cannot be used as the continuous power generations for overloading conditions. Right? So these are few disadvantages of diesel engine power plants. We talked about diesel engine power plant. Okay, uh, and the mm, engines which can used for the diesel engine power plant, right? Then applications, advantages and disadvantages. Now we will talk about the plant layout, how the plant layout, what are the associated components for the successful operation of the diesel engine power plant. So it consists of the engine generator, which is the main part, that is also called as the heart of the diesel engine power plant, which is situated or founded or mounted, we can say, onto the main foundations along with the vibrations and dampers, right? So that the vibrations effects can be brought to the tolerable value. That's why the vibrations dampers are provided, and it is directly coupled with the engine's crankshaft, camshafts. Okay, so another is the filter, oil air filter and supercharger. So the atmospheric air is supplied to the engine cylinder from the intake manifold after passing through the air filter, so that the impurities and dust particles can be removed, and the pure and purified air is uh, supplied to the engine cylinder. Okay, and also the supercharger here supplies the sufficient amount of air inside the cylinders for the complete combustion process at the higher pressure, so that the efficiency at the great extent can be achieved. So this is the supercharging and air filter process. After of this we see there is the um, we need cooling systems, lubricating systems, governing systems, all this. So systematically we'll go, then there we need the exhaust systems. So exhaust systems is very essential components or systems which is required in diesel engine power plant, because we see in any IC engines the combustion takes place inside the cylinders at the very confined volume, so which causes the noise, which liberate out the noise and vibrations, and also heat generated, so that gases, the combustion of the fuels comes out in the form of gases like carbon dioxide, carbon monoxide, sulfur, etc. So that has to be minimized. So to take care of that, an exhaust systems with the proper arrangement of a pipe and silencers is provided and situated inside into the engine, so that comes under the exhaust system. Now we'll talk about fuel system. What is fuel system? So for the continuous operations of the plant, diesel engine power plant, the fuel must have to be fed or have to be supplied, okay. From the fuel injector or barrel, we can say, from the fuel tank. So to let this happens, there is the several component uh, essentials for the fuel injection systems, that are the fuel tank, supply tank, right, fuel pump, pipes, strainers, heaters, these things required, okay. Then another is the cooling system. So what is cooling systems, why cooling systems is required? We all know during the combustion process in a heat engine or IC engines, almost the engines operates at about 2000 degrees Celsius. This is very high temperatures that has to be taken care of, because if it's not minimized, then it deteriorates the life of the components. There will not be proper functioning of lubrications, so several defects will be there. Efficiency will reduced. So to take care of this, the cooling is provided. So the cooling can be done in two ways: air cooling, water cooling. In water cooling, again there is a different ways, right? Thermosiphon, thermostat, forced cooling, open circuit, closed circuit cooling system. So this all cooling systems we will discuss in another videos or later, if it will be possible to cover up in this video only. So this cooling systems requires cooling water, that is called as the cooling tower, you can say. Cooling tower, pump, cooling pump, it requires cooling pump, and pipe, okay. So these are the accessories which is required for cooling purpose, okay. Now move to the lubrication system. So what is lubrication system? We all know, and why lubrication systems is important. So to protect the mating parts from the frictions, lubrications is being done. Lubrications is done in order to reduce the heat as well, and proper functioning of the parts, enhancing the life of the components. For all this purpose, the lubrications is very necessary. So different types of lubrications can be selected for the um, lubrications purpose. Depends upon the mating parts, their functionings. So we can select on the basis of their that. So this diesel engine power plants consisting of several components and lubricating systems, like as lubricating oil bath, lubricating pump, filters, okay. So these things are the parts in the lubricating systems. Then we move to the uh, governing systems and starting systems. So why governing systems is necessary? We all know that engine speed fluctuates or varies on the varied load conditions, right? So to take care of that, if the speed is varied on the varying load conditions, the frequency of the current generated will also vary. So to maintain that, we need a governing systems to keep the constant speed. So the governor is a type. What governors do is, governor is the spring arrangement systems which automatically supply the fuel, uh, quantity amount of fuel on the basis of the load applied. If load is higher, then high fuel will be supplied by the governor. If load is lower, then the less amount of fuel will be supplied by it. So that comes under the governing systems. So another one is the starting systems, right? So the starting of diesel engine power plants or any engine power plants, heavy engine if you talk, then it's the compressed air. Compressed air uh, is supplied uh, to the engine cylinders through the intake manifold, and which uh, um, pushes the piston down, and other remaining strokes completed in 2 to 3 revolutions of the crankshaft, and then the automatically engine will start. So this is used for starting of the engines. And starting can for light vehicles, light engines, the starting can also be done by the electrical motors which can run by the dry batteries. So these things comes under the starting. Those all are the plants layout, diesel engine plants layout. Now different accessories, this is essential for the diesel engine power plant. So what are that accessories? So we already discussed in plants. There will be a fuel injection system, cooling system, lubricating systems, starting systems. This all will be discussed. So in details. So fuel system. Let's talk about fuel systems. What is fuel systems? Fuel systems uh, is the one which supplies fuel to the engine cylinders for the continuous operations for the generation of a power. In diesel engine, uh, the fuel from the tank is supplied to the fuel injector, and which injected at the right time at the end of the compression of the engine cylinder, and the combustion takes place. So this comes under the fuel system, where the proper amount of fuel must to be supplied into the engine cylinder for the efficient or smooth operations, to achieve efficiency at great extent. So the design for the fuel systems is the main parameters. So design should be done on the basis it's of air fuel injection systems or airless fuel injection systems, which is also called as the solid injection system, right? So we will discuss what is air fuel injection system. In air fuel injection system, the fuel is injected from the fuel injector or barrel at a pressure of 50 to 70 bar. This is not much pressure, to the end of the compression stroke into the engine cylinder, and hence the combustion takes place. It were used uh, before existence of airless or solid fuel injection systems, because the pressure developed is very low, less in air fuel injection systems. So it has been totally replaced by the uh, airless injection systems, which is called solid fuel injection systems. So in solid fuel injection systems, the fuel is injected, the high pressurized fuel, which is atomized fuel, is injected into the engine cylinder from the injection barrel or injector at the end of the compression stroke, at the high pressures of 100 to 150 bar may. So this can be done by several types, several ways, like as unit fuel injection system, distributor fuel injection system, pump fuel injection system, common rail fuel injection systems. This all come under this. So what is the unit fuel injection systems? So a unit fuel injection systems is one in which the injection of the fuel is being done by the help of a plunger at a higher pressures to the engine cylinder. So this whole component consisting of a plungers which is mounted on the spring by the rocker arm and push rod which is uh, mounted onto the cam shaft. So the cam rotates through the timing gear which pushes the push rod, and the rocker arm get set it in motion, and which pushes the plunger, and hence the plunger push the fuel supplied the fuel at high pressures into the injector barrel, and through the nozzles it's spread into the cylinders at the end of the compressions for the combustion process, right? So during this process the spring is attached, so the loaded spring delivery uh, is set during the high pressure of nozzles, brings is actuated by the this high pressure nozzles, so that brings again back the plungers to its original positions or previous positions, and against the same process continued, and the fuel injection systems uh, takes place, which is called as the unit fuel injection systems. Then another one is the distributor, that pump fuel injection system, distributor fuel injection system, pump fuel injection system. So in pump fuel injection systems, the individual pumps provide or supply the fuel through the high pressure line to the individual's nozzle, and which spread the fuels atomized fuel at the required time of ignitions into the engine cylinders one by one. Its arrangement is made in such a way that it's actuated by the cam mounted on the crankshaft. So arrangement is made in such a way that the required pump supplies the fuels at the required times when it is required for the combustion inside the cylinder. So similarly, all pumps operates one by one simultaneously, depending upon the corresponding uh, fuel supplied which is connected to the injection barrel, right? So this is the working of we can say that the pump injection systems. Then there is the distributed injection systems. So in distributed injection system, the oil from the main oil tank is pumped through the uh, supply pump to the one is supply tank, we can say, and that tank again supplies the uh, fuel to the uh, distributor distributor unit, which distributed fuel through the high pressure uh, mm, line to the separate nozzles, and that is being spread into the engine cylinder for the combustion process. So this is only simple about the distributed fuel injection systems. Similarly, there is the common rail injection systems. The same things happens, but there is the common rail, and which is actuated by the plunger. So the plunger length movement decides the amount of fuel that has to be injected inside in it. So this comes under the common rail injection systems. It is in another video, if it will be possible, if I will be making if I will be making another video, then I will explain these all things with a pictorial view, and in details I will explain. This is just a theoretical video, we can say. uh, Another we have to talk about the cooling systems. What is cooling systems? What types of cooling systems? We already discussed what is the necessity of cooling systems. Right. So here the cooling systems can be done by air cooling systems, water cooling systems. Two types only. So the water cooling systems is the thermostat cooling systems and forced cooling systems. Forced cooling systems are open. cooling systems are called as the open circuit cooling systems, and this is single cooling systems. And another is the double cooling systems, which is called as the double closed circuit cooling systems. And then is the thermosiphon cooling systems, right? So these are the cooling systems which we will talk about. So what we all know about the air cooling systems. What air cooling systems is? So it's simple. The cooling is done with the help of air. So the auxiliary fan which supplies the which blast the air particles onto the engine cylinders, around the engine cylinders, which is attached with the fins, so that the exposed area is increased and the cooling can be achieved. So this is the air cooling systems, which is only done by the help of the air, that comes under the air cooling systems. So they have several advantages of air cooling systems. There are several advantages and disadvantages as well. So basically, if you have to talk about the advantages of air cooling systems, then we can say it is simple in constructions and workings, right? And it can be used on the extreme climate conditions where water may freeze, right? It can be used in the place where water are not easily available, like in desert, if you have to say. Then at that conditions, the air cooling systems may be efficient or effective. And other advantage, if you have to talk, then um, air cooling can easily be set, means it can easily operated. So that's all are the air cooling systems. Okay, now there are several disadvantages of air cooling systems as well. So some of the disadvantages, like the cooling is not efficient. Even cooling cannot be done at the great extent, so that the engine um, may not cool. Okay, and engine warping can take place. Warping. Air cooling is limited only to a few part, or the small diesel power plants or small power plants only. Okay, it's limited because it's efficient. It is not much efficient cooling systems. Now another one is the water cooling system. So water cooling systems is more efficient over the air cooling systems. And if it is it has different types, like as thermosiphon, we talked just thermosiphon cooling systems and forced cooling systems. So thermosiphon cooling systems, and basically, if you have if you are talking on about the water cooling systems, then the cooling is done around the engine cylinder with the water jacket, or that is called as the cooling jacket. um, okay, so in thermosiphon cooling systems, the cooling is done without the force, without the help of a pump. So here the density makes the flow of the uh, coolant, okay, or flow of the water. So when the cold water circulates around the engines, it gets heated, and it is if it get heated, then the hot water get low densed, and it get collected into the upper tank overhead of the radiator. And there is the cooling fan, and which cools that hot air, and it's collected into the lower radiators, lower head of the radiators, and again from there it circulates into the engine cylinders, which is situated above the engine cylinders, because this is on without the force. Yeah, and then another is the forced cooling system. So forced cooling systems consist of several types. Right, we all discussed on that open circuit, closed circuit, thermostatic cooling systems. So these are the cooling systems. So in open cooling systems, the cooling is done without the help of the purifier unit or heat exchanger. so that the cooling is done at the efficient way, but there is the chances of corrosions, and the corrosion of the part may takes place, right? So that is the open cooling systems. And in closed cooling systems, the cold water circulates around the engine cylinders, and then it passes through the purified units and heat exchangers, then again collected into the cooling tower, then again pumped into the engine cylinders, and circulation is being continued. So this comes under the closed cooling type systems. Now the last one is the thermostat cooling systems, right? So in thermostat cooling systems, its functioning is more similar like thermosiphon cooling systems, but it is situated below the engine cylinders, and there is the use of a pump, so that the pump pumps the cold water from the radiators and circulated to the engine cylinders, and then it's sent to the radiators again to collect at the overhead from the bypass. If it is not necessary to cool, then directly it is sent to the circulating units, and if it is necessary to cool, then it is sent to the radiators, and which cool it down and then sent to the circulating units. So this is the thermostat cooling systems, right? Now let's talk about the lubrication systems. So we already discussed why lubrication systems is necessary. So we'll just talk about the types of lubrication systems, how many ways the lubrications can be done. So it can be done by lubrications can be done. Splash lubrications is called that. Splash mist lubrications. Okay, so one is the mist lubrications, another is the wet sump lubrication system. So wet sump lubrication systems consisting of the splash lubrication systems, okay, then pressure feed lubrication systems, then semi pressure feed lubrication systems. So this is the type by which the lubrications is being done. So mist lubrication systems is one in which the lubricant is used along with the fuel itself in percentage of 3 to 6%, right? So when the oil is used or it is vaporized, then the lubricant is used for the lubrication purpose in the machine part. So that comes in mist lubrication. Then wet lubrications, that is splash lubricating systems, pressure fed lubrication system, and semi pressure fed lubrication system. So in a splash lubricating systems, the main uh, in connecting shaft, there is the scoop like structure. So that scoop like structures uh, pass through the uh, lubricant collectors, and it places the lubricants to the cylinders and gauge pin pistons, so the lubrication actions is being achieved or being done. And similarly there is the pressure fed lubrication systems and semi pressure fed lubrication systems, so which will be discussed in next video, because the video is being very long. I do not want to make it too long. So in next video I will discuss the lubrication systems in details, and then the charging systems, okay, then supercharging also. uh, these things I will cover in the next video, and then transfer systems also I will discuss, and the units will be completed, and after that I will make one concluded unit along with the figures and numerical formula. So let's see in the other video.